Hello, everyone. Welcome. My name is Kylie Pena, and I am your session chair. And you are in AI in Production, Intelligent Tools, Automation, and Education for the Next Era. I am also a SMPTE region governor for Hollywood, and I am so interested in this subject matter, and I'm happy to say that we have 3 really fantastic papers for you today. It seems like AI is just in everything, even your refrigerator now, but it's slowly or quickly becoming far more integrated and useful. And I think that these papers will show you some really interesting use cases and experiments. If you want to ask questions of the speakers, there are QR codes. There's a QR code right here. And if you missed that, they're kind of posted around the room. And then we'll have a little time at the end of each presentation for some Q&A. So first up, we have AI-assisted post-production, enhancing workflows with AI, image interpolation, and object detection. And your speaker is Brian Gaffney, Vice President of Software Product Division at MTI Film, leading the development and commercialization of industry-leading post-production tools, including Emmy Award-winning DRS Nova and Cortex. All right, take it away, Brian.
Testing. Awesome. Everyone, as Kylie said, thank you, Kylie, for the introduction. By the way, this woman will run Hollywood one day, I believe it. So I'm very excited to have her invite me here today and talk. As I said, I'm the Vice President of Product at MTI Film. It's always an honor to speak at a SMPTE conference. This is my 3rd one over the last 32 years. My first one was in 1993. It was on the Matrox Millennium chip, which was a chip that was equivalent to like a Grass-Valley 110 switcher. And at the time, it was pretty revolutionary. This was, 8 years before Blackmagic even came to be. But it was really the first phase of that software architecture controlling hardware versus hardware controlling hardware. So I kind of started on that 32 years ago and had the luxury to work for a lot of great companies. 5 of the products that I've had a chance to bring to market have won Academy Awards and 4 have won Emmys. So today I'm going to talk a little bit about AI post-production and the enhancement of using AI tools, not so much for artistic tools, but actually replacing some of the procedural things that we typically do in post-production. So as we talked about, I'm going to get into a little bit of the details, not just about the tools, but the underlying architecture of how we actually trained these models, what was actually our thought process driven by the user stories, the use cases, and then how we came to be about implementing this technology. So my introduction is the convergence, as we know, of artificial intelligence and traditional post-production has really introduced new efficiencies into the creative workflow. Beyond the generative models, like from a Midjourney to a Runway to a VO to a Sora, using, those for specific storytelling processes, I want to talk about AI systems addressing bottlenecks in our production workflows, specifically using video frame interpolation, intelligent object detection, and also generative frame reconstruction. These are the 3 areas I'm going to focus on today. So video frame interpolation is the process really of creating the in-between. It's looking at the actual clip and looking at the motion and being able to understand that. And like traditional methods that would, say, change frame rates would typically duplicate frames or drop frames to actually get from a traditional telecine or inverse telecine process. The difference here is VFI, or video frame interpolation, is actually synthesizing new frames in between. And how this actually works is we use an algorithm called the Rife algorithm. Rife is a public open source technology. In fact, our Flame artist is the one that actually introduced us to it, because Flame had the ability with optical flow to do sort of not frame rate conversion, but frame duplication and so on. And before they used to just duplicate frames, but they started using Rife. So we looked into it, and it's a public source solution that I'll just open up. You can actually get to it publicly. There's a GitHub solution out there. This GitHub solution has all the information about Rife and what you can do to implement the current version. The problem we uncovered, though, initially was that Rife only worked at 30 frames per second at 30p, and it also used optical flow using the system called PyTorch that we implemented initially, but it was quite slow in its rendering. However, it did the job, and we were able to take movies that we were remastering and use this algorithm to improve on the optical flow process for doing that. It was looking at the in-betweens, but our challenge was to actually get it to work at all the frame rates, not just 30p, because we wanted it to go from 30 to 2398 or 2398 to 25 and all the various frame rates that were typical in post-production. So our challenge took us about a year to take this right algorithm, optimize it for that, go through the training, and continue to work on it. Let me just show you a couple examples of what this can look like. I'll come back to here. So, blow this up for you. That looks like shit. That is not the algorithm. That's the compression playing through this projector, but it's going to be a little hard to tell in this view here. But look at the motion, not sort of the compression of these objects, because it looks great here, but I'm not sure why it looks so poorly up there. But the background in there is you see that moving. Traditional, when you're dropping frames, when you look at the sort of background motion there's like a staccato effect happening. But when we run it through the AI, we can actually, through the interpolation, get a much smoother motion on that, especially when you look at the background of the hill beyond that. So I'm going to go back to kill this guy here. There's another example down here, I think, which is a little better to look at. Not this guy right here. So we've seen a lot of car commercials, and typically the motion of the cars, especially on the fronts, the grills, the tires, when you're shooting these things and then you need to go to a different frame rate, you get that sort of drop frame effect. Here, using the MTAI, you get a much smoother motion in that. We'll come to the booth and we'll look at it and the setup. You'll see it a little better. So let me go back here. So using the same algorithm, the Rife algorithm, beyond just doing frame rate interpolation, we're able to use it for the motion interpolation for a generative effect. So quite often we would run into doing film restoration, jump cuts, slugs where the actual film broke, and to keep audio in sync, they just put like 3 frames of black, stuck it together, but there's no picture there. In fact, Charlotte Barker from Paramount Pictures recently has been going around doing a tour talking about the restoration they did on Sunset Boulevard. Sunset Boulevard was actually restored just in 2012, so why would you need to restore it again here in 2024, 2025? Well, there were 14 frames missing still in that movie with their restoration that they couldn't recover. So using this generative approach with our tools, they were able to recover those frames automatically. Now, you've heard about large language models that are used often in the generative AI space. Well, we're using not a LLM here. We're using an inference model. We're actually using this tool with Rife to actually interpolate the motion, as I said, in between the frames. So in this case, we were always looking at sort of the jump frame and the sort of slugs that we could repair. But then we ran into these issues with shots that just couldn't be fixed. And we thought, well, let's just imagine they're not there, and we'll mark in at this frame and jump to another frame. We'll interpolate between there. And we did this recently for Topkapi. This is a better example where this movie Submarine, which is a Frank Capra collection, and Sony recently released in a box set, and they had this scene with just this raking video that I'll show you that nobody could seem to fix. And so we used a combination of our standard manual tools to clean up frames before and frames after, leaving about 3 frames of damaged images, and then we used the generative AI to replace it. And it was very impressive. Let me show an example of that. So I have a couple of examples that'll run through this. Some is showing warping of film from Designing Women. We just recently had to remaster that, take it from, the 7/496 up to, UHD, do an HDR pass. But we had quite a bit of vinegar syndrome warping. You'll see some effects on that. Missing frames that have been replaced, all using this generative AI process, which is really not, again, an LLM model approach. It's an inference model approach. So let's take a look at that. So this is also from Topkapi. On the left-hand side, you can see people are walking through the door. There's black frames. The car is moving. The flags are moving even after the shot. And on the right-hand side, you can see how the AI replaced that. Again, it's sharp and crisp, and this is a little soft and compressed up here, but that's a YouTube playback. This was also from Topkapi, this horrible, terror that's running through the film. Normally this would have taken like 4 days going into flame, making some concessions to it, but being able to stitch it back together. And AI did it for us, within, a couple of hours. The same one here, I'm just looping it through. There's a lot of problems here. There's a jump cut in the beginning. There's scratches and vertical, just typical noise, but then that horrible raking that takes place. And again, there's about 9 frames total. And what we did is we sort of cleaned them up manually on a few frames and then generated the in-between. And here's the result. So the jump cut was fixed. That raking is gone. The only thing you can maybe notice is in her hat, as she moves her head, there's a little bit of moire that the AI kind of probably introduced. But overall, they were going to release it with that box set, with that horrible raking, because they couldn't fix it. But now they were able to recover that, again, using this Rife algorithm as an inference model to look at the motion and the in-between. There's no referencing, actors of a different type and reconforming it. It is the talent. So let's get out of this. So again, we're looking at using this algorithm for two different disparate things, frame rate conversion and then a generative AI replacement. The other approach we have taken to using post-production is using object detection. So object detection has been used quite a bit, in everything from military to ID to detection, but we wanted to use it for a specific use case of finding the closed slates when we're doing dailies. We do quite a bit of dailies at MTI, shows like 911 and Watson and, Blade and a few other shows. And through that, we have quite a bit of training data on there, but we really wanted to save the time of people going through and looking for a closed slate. So we wound up using the Ultralytics YOLO model. The YOLO V11 is currently the model we're on right now. Ultralytics makes this tool, YOLO, you only look once, detection tool. And our model that we trained on, this object detection model, was really to find the slate presence and also the 2 states that we were concerned about, open or closed. We didn't use OCR to actually look through and find the slates. We used this YOLO model for object detection. The time code and the metadata we pulled from the sound when doing that, but by integrating this AI object detection, the system really is searching for the exact point where the clap is closed, because that's really the most important part for us to then sync sound. So initially when we went through this, as I say, we have tons of training data. We do lots of dailies, but we actually overtrained the model. We did about 20,000 annotations, manually drawing these boxes around slates after slates through scenes and not getting good results. We kept getting, efficiencies of 80%, 85%. Then the next day we go to 70. We're like, what's going on? We're training everything. We wound up speaking with Ultralytics to find out we were actually overtraining the AI. We were giving it too much information. What we really needed to do is just give us 3 things. They wanted to know, what does a closed slate really mean to you? In this case, for us, it was the point of finding out, where the chevrons were actually closed, where that point and shape was. That was the most important to us. I don't even care about the lower part of the slate. It was this. So we gave it 2 states, sort of showing the chevrons closed and showing the chevrons closed with, a portion of the slate in it. Then we also trained it on what is an unknown slate. Quite often, you have multiple cameras and you're lucky if you even get a slate sometimes, or you get not the slate that you really can see any information of it. You just might catch the lower part. So to us, we told the AI, this is what we call unknown. And then we also had the state of it's open. Could be anywhere in the scene, but if the chevrons aren't touching, they're open. This is called an open slate. So, let me just go back in here and actually I want to show you one more example of this. So just in practice, for doing, dailies and so on, you're typically taking your audio and your video, you're bringing them into some application, Resolve, Colorfront, whatever tool you're using for your dailies. And then you sit there and you import that media manually, you drop it into your bins, you go there and you start searching, each clip and looking for things. Well, we just told the AI to do it. And now it actually said, okay, I found 7 slates here. I don't know the state yet, but in the lower left-hand corner, it's running the AI slate detection. And all of a sudden, boom, 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 it finds these 7 slates and it found the state where they're closed. Now the operator can go in and typically you want to, just not assume AI is correct. You want to vet those, but you can go through each event and kind of go frame before, frame after, hear the clapping of the slate and go, okay, that's great. And you can magnify it up, make sure that, the chevrons are truly closed. But the AI did all that for us, finding about an efficiency between each session of about 15 minutes per daily session. So when we're doing, 4-6 shows a night and we save an hour and a half, that's actually meaningful revenue savings and also time efficiency. So we're really excited about this. And I think, the next step of this object detection would be what else can we find in the scene? There are tools out there, 12 Labs and others that'll tell you what's happening within a scene or, transcribe it. But what about finding me boom mics or finding me, reflections of the, camera crew in a window or your glasses? So this is another area where we can start to apply object detection. So, let me just get out of that real quick. And so the object detection training was, I think, key to our process of getting slate detection working. And again, it was really this process of annotating the data, making sure we were annotating the right data, working with your model to understand, how it responds to it, and then improving on that efficiency. And right now we're running at about a 98% efficiency. Again, most of the stuff is, sometimes when it doesn't find the slate, it's typically an environment variable. They're at night. There's, maybe a flashlight, on that. It's raining. There's a plastic bag over the slate. The other things that they do in an environment scenario. There's lots of drone footage these days and, people don't stand up in the air and clap a slate, right? They just let the drones roll. I've seen people, they develop these large slates that, they can hold up to the camera. They don't have any chevrons on them. It's just a marker for sound. Quite often, you go through all that and there isn't any sound with these drone footage. It's just, an effect capture. So the efficiency of it having going through, sometimes you don't get a slate at the beginning, you get a tail slate. So the algorithm looks through the beginning of the clips, looks through the first 10 seconds. If it doesn't find a slate, jumps to the end, looks 10 seconds backwards, and then kind of moves inward until it finally finds a slate or doesn't. But in the case, it's really, I think, improve the efficiency of our dailies process and allows the other step that you would do when you're doing dailies, looking at the reports and the notes and combining all this information to make sure your QC. And the reason we do dailies to report back to production if there's any issues. We found that quality has actually gone up, feedback we've gotten from the producers. So all 3 of these listed techniques that I've been talking about, the video frame rate interpolation for frame rate conversion, the video frame generation for restoration, and also object detection, our main goals were to really provide efficiency and assistance to the artist, not to replace them. These aren't creative things that nobody really wants to sit there and scrub a slider back and forth till they find the clapper. Nobody wants to sit there and, have to, go into a Flame Bay or export files from one application into another file, they kind of now have 2 different people working on something. They want to keep that coherency of a single artist working on the product. And this is where, again, AI assisted efficiency has really been our focus. So what happens when it doesn't work though, right? So, the AI sounds great until it doesn't work. And sometimes in the video frame interpolation, that motion that it estimates, can sometimes be wrong. If I'm going from 24 frames to 25 or from 24 to 60, I'm creating entirely new frames. It's not repeating the existing frames. It's creating new content. So there are going to be some differences, but there's always that hallucination effect that might come into play. And we saw more of that when we were using Rife with PyTorch. We found that lateral motion coming in from a frame, off axis could sometimes, for a frame or a frame and a half, cause an optical distortion. When we switched to the Tensor RT technology within NVIDIA, we improved on that dramatically. There's still some artifacts, but we reduced it by, it felt like, 90%. It was quite an improvement. Plus, we also got a speed improvement which was almost 10 times the speed improvement over the optical flow approach, of just using Rife and PyTorch. So Tensor RT integration with Rife really gives us faster than real time at 1920 by 1080. At UHD, we're around 8 frames a second, where by earlier stamps with PyTorch, we were running about 1 frame a second at 1920 by 1080. So even though it did a great job, people didn't find it as useful because of the process. The other thing you need to have is you need to have scene breaks. You can't just put down a reel of a movie and expect it to work because, black frames inserted, breaks, cuts, all that kind of stuff. It needs to know if it's looking at the motion in between, and all of a sudden there's a hard cut. Well, that's a hard motion interpolation to interpret. So it'll cause it to, sort of flounder. So we put in the scene breaks to make sure, or using an EDL, because the way the algorithm works is the first frame and the last frame are always, the same from the original source. We don't modify those. We only work at the in-between of that. So keeping, and checking those marks is key. A lot of time we do AI shot detection, and it's quite cool, except for I might have effects, it's like almost a optical effect or a flash frame or something that, epileptic type, flashing, that the algorithm thinks, oh, that's a scene break, and it puts in, these breaks that are false. So you need to vet those and check that out. But once you source that out, or if you have a clean EDL, or if you are doing a Dolby Vision project, and you're interpolating, say, going from a 2398 movie to 25 for a distribution in the UK, and you don't want to affect the audio, you use this MTAI frame rate interpolation, and then you vet the cuts, make sure everything's good, and drop the audio in. And we have seen a really high quality of work with that over the last year. The improvements in both the Rife algorithm as well as the quality that we got from going from PyTorch to the Tensor RT really improved things dramatically. So this is just an example of where it could fail. On the left-hand side, you have the original source, and on the single frame, if you sort of look on the left-hand side, the lapel of that jacket coming down, there's sort of a line going through that shoe. It's not the line of the jacket going through the shoe. It's just a line on the shoe. But the AI then, well, where does the shoe go? Is it behind the jacket, be in front of the jacket? It kind of, had that hallucination effect I was talking about. So we incorporated tools to be able to paint back in those effects, or just insert from the source into the destination, so you can go through and QC these processes. But you definitely wanted to say, I would say with AI, is your QC has to go up an order of magnitude, because you save time on the generation, the workflow, but you have to make sure that you're generating the right stuff. So overall, as I wrap up here, I want to leave some time for Q&A. We're going to continue down this pathway. It's been already 3 years of our introduction of the AI frame rate conversion tool. We've done several movies, and in our remastering process, quite often we get a lot of 30 frame shot film that was used for, an effect in the setup that we now have to take to 2398. So we've really improved on this quite a bit. The slate detection is our most newest introduction. That came out around April this year. We have about 6 shows that are currently using it in production. This efficiency, as they say, of 15, 20 minutes per show is meaningful, especially when you're at 2 a.m. doing this type of stuff and you want to get home sooner, or you want to be able to maybe do more shows. You add it up an extra, 4 times 15 minutes, you have an hour that you gain, which could be another show. So our plans are going down this pathway is to really expand on the generative frame inference, but now focus on noise reduction and flicker correction. We have a really high quality upres tool. We have a shared patent with Samsung. All the upres in the Samsung monitors is MTI Samsung, and in the software it's MTI Samsung. And we want to improve on that. When we do upres is great, but if you have flicker, it's just like SDR, HDR. You see that your eyes really respond to that flicker. So we have a really high powerful flicker correction. We want to train that with AI. We want to take, the fine scratches, that fine noise stuff that sometimes we outsource to India on projects and then bring in and do the manual work. We'd like to see that. There's a company here, Helikai AI, showing off some stuff on that, or Topaz. A lot of people are coming after us in some way with the AI side of things. And so we want to stay ahead of the game. MTI has always been about purist and, high quality and respecting intent. So we don't want to accept, plasticky skin or, just heavy-handed noise reduction. We want to respect the grain that was there in the original, project and be able to reproduce that, but also take away the fine, scratches and details that are unwanted. So we're looking to use AI and enhance that for speed and motion. And the other side is in going further with our object detection, as I said, especially in the QC side for looking at boom mic, crew reflection, signage, find me a Coca-Cola sign and, blur it out if I don't have the license rights, or blur it out or replace it with, the Pepsi-Cola sign. So last thing I'll say here before we jump into Q&A is that I don't believe AI is really going to replace artists with these tools, but it will really help redefine your workflows. And you're going to have to think about this as our cost structure goes down, the expansion of, creative teams out there gives producers more leverage to push rate down. So you need to ride with that if you want to stay in business, and AI really can help you assist in that with the efficiency, not firing a headcount to give you profit back, but allowing you to do more jobs. So thank you, everyone. If you did happen to put any QR code scans up there, if Kylie's got any questions, I'd be glad to answer them.
Yes, we have a few questions and time for a couple. Obviously this is a really interesting, important topic. And as someone whose first job in LA was in dailies, no, I did not want to do that at 2 a.m. So thank you for your service. So one question was, have you had to deal with any ethical considerations using generative AI with talent on screen?
No, we haven't, because again, we're inferring the existing talent. So in Sunset Boulevard, when William Holden walks across the road to go buy some cigarettes and there's cars crossing him, the camera's zooming behind him and he's going down in size, and all of a sudden it goes blank for 5 frames. And then we generate that. Well, we're not generating another actor's talent, or it's not pulling from somebody else's face and reconstructing William Holden. It is William Holden. It's just taking the reference of the existing frame, inferring that motion in between and redrawing it. So it's a different ethical concern because we're not adding, Tilly Norwood in replacement of, William Holden.
Great. Another question is, do you think that you will be able to tune the interpolation model to reduce hallucinations?
Yes, and we've already seen that when we were using just Rife standalone with PyTorch. We fought more hallucinations, especially on the frame break side of things. But the TensorRT tools that are integrated with the NVIDIA tool set really improved on that. And so I think further training of that and more examples of it will improve upon it. So I think the speed and then the paint tools that we added in to correct it, there are always going to be some of that, but it's getting better.
Great. And have you looked at using readable regions of damaged frames as further input so prediction is only needed for damaged regions?
That's a really good example. One of the things we're really looking at is textless, or creating textless content from content that has text on it. So lots of times in restoration, they'll find some missing elements, but it's got titles on it that, are wrong, or they want to remove. And it's really hard to remove titles from existing stuff. So we can infer the whole frame replacement and then just mask out a region and generate within there now. So we're trying to do that specifically around this challenge. We haven't had the greatest results, but we're working towards it.
Very cool. And you mentioned the need for increased and new areas for QC. What was the most surprising impact that changed your workflows?
Good question. I think the most surprising side of it was really having it detect stuff that we didn't even know was a problem initially, especially on map detection and stuff where we had looked at the image, saw, didn't detect any problems, and then the AI was able to flag stuff for us. So it's like having a second set of really good eyes in the room. And to me, that's what separates out a good colorist from a, normal colorist or a really good QC person. It's really that, just those eyes that can catch those things, see what is noise pattern or vertical lines and things that, you might just not even see in motion, but being able to catch that is really separated talent from, normal talent, I should say. But AI now sort of brings my, standard normal talent up to expertise level because it adds that sort of quality of eyes on top of it. So I think it'll raise the bar of our, talents and help us learn from each other better.
Excellent. Well, thank you very much, Brian.
Thank you, Kelly.
A lot of time for questions here, but thank you so much for that. That was great. We're going to move right along to our next session with a little bit of furniture rearranging here. Okay.